Welcome to this tutorial on integration by parts. Now, when do we use integration by parts? Well, it's when we have integrals that involve the product of two functions. And these functions generally are, say, x to the power n times a trigonometric function. So, for instance, x to the power 2, where n is 2, times, say, a trigonometric function, say cos 2x, with respect to x. Maybe I'll have x times sine 2x, or x cubed times cos 3x, maybe, dx. Okay? What other types can we get? We could get, say, x to the power n times an exponential function. So we could have, say, x times e to the 3x dx. Okay? Or even x squared e to the 3x, x cubed e to the 3x, and so on. What else can we have? Well, we could have, say, x times the natural log of x dx. So here we have an x to the n function, n being 1, x to the power 1 times a log, natural log function. The list is endless. I could have maybe an exponential function, say e to the 2x multiplied by a trig function, let's say sine 3x dx. Okay? Now, to integrate any of these, we would use this formula. And you'd find this formula in your formula book. And the first part is u, and normally that is the first part, although there are a few special cases, we'll go into that later, but u could be this x squared, for instance, or x in this integral. And dv dx is the second part, which would be, say, the cos 2x here, or the e to the 3x here, and so on. And what we have in this formula is that it is the first part multiplied by the integral, v being the integral of this part here, dv dx. And then we would subtract the integral of the part we just integrated and multiply it by the differential of the part we called u. Now that might sound complicated, but really it is quite easy with just a little bit of practice. So we'll do an example first of all, just a basic example just to get you in the groove of working this out. So we'll start with, say, the integral of x sine, let's say 2x. With respect to x. And in this example, my u is going to be the x, and my dv dx is going to be the sine 2x. Okay? So, according to the formula, it's the first part, the u part, so I'll write that down. It was the x, so I'll write that in brackets. Always a good idea to write each part that you do in brackets. And then we have v, which is the integral of dv dx. So I need to integrate sine 2x. And what that will be is negative a half cos 2x. Okay? And note that I've put that in brackets. I make no effort to write the minus a half at the front. Okay? I just leave it in the brackets. Then it's minus, according to the formula, the integral of v being what I just integrated. And if I don't simplify this, all I have to do is just copy this, what's in this bracket, straight in here. So I'm going to copy that in as minus a half cos 2x, and then according to the formula I multiply it by the differential of the part I called u. And the part that was u in this question was the x here. So if I differentiate the x with respect to x, I get 1. And I'm not going to leave it out. I'm going to purposely put that that's 1 so the examiner can see how I formed my answer. And this is integrated with respect to x, so don't forget the dx on the end. Okay, now the next stage is just to simplify this line, the right hand side here. I'm not going to work out any integrals, just simplify it. So this first term here would look better as minus a half x cos 2x, or even better still maybe minus x over 2 cos of 2x. And looking ahead at this integral here, I'm not going to integrate it, as I said, I'm just going to tidy it up. So the minus with the minus here is a plus, so put the plus down. Notice I don't rush in and just write a minus or whatever. Pause, just think what your sign's going to be. So plus. And also another point here, it's a good idea to take constants out the front of an integral. So I'm going to put that as a half the integral of simply cos 2x. Okay, so cos 2x integrated with respect to x. Okay, moving on. All I'm going to do now is perform this integration down this end. So this first term is just going to get written in again, so that's minus a half x, or minus x over 2 cos 2x, plus, now I know you could most probably go straight for that answer, but I'm purposely not. I'm just going to write a half, that half there, and then the integral of cos 2x is a half sine 2x, so that'd be a half sine 2x, and then don't forget the constant of integration plus c. All I'm going to do now is just clean up this term at the rear here, so I'll write the first term in, minus x over 2 cos 2x, and then we have half times a half is a quarter, so that's plus 1/4 of sine 2x, and then plus the constant. And that's essentially it. You might like to just tidy this up further, but nonetheless that is the integral. Tidying it up, what could we do? Well, we could pull out a quarter, okay, and if I do that, we'll have a quarter out the front. Also, I don't like starting with a negative term, so I'm going to work off this term here, and we'll have sine 2x, and then minus, and we go on to this term, and so a half is essentially 2/4, so that's going to be 2x cos 2x. Okay, and then I'll put my plus c at the end, like so. So that's a more attractive, more simplified answer than the line above. Okay, so that's a very basic example showing how we work integration by parts.